In this video, we will solve a problem that requires us to use the standard normal curve and use the standard table. Exercise or example 2.9, brisk walks and calories burned. A brisk walk at 6.4 kilometers per hour burns an average of 300 calories per hour with a standard deviation of 8 calories. Attorney Jane Kalika leaves her office to take a brisk walk inside a mall for 1 hour at an average speed of 6.4 kilometers per hour. Assume that the calories burnt for brisk walking follows a normal distribution. What is the probability she burns more than 280 calories? What is the probability she burns less than 293 calories? What is the probability she burns between 285 and 320 calories? So what is our strategy to solve or to answer these questions? First, we will convert these data values into their equivalent z-scores using this conversion formula. The data value x minus the mean all over the standard deviation. And then we will locate the z-score in our standard curve and shade the region that corresponds to the probability. And we will use the standard table to obtain the area of this shaded region. So let us convert these data values into their equivalent z-scores. Again, the mean is 300 calories, the standard deviation is 8. So these are the z-scores. So let us show it for 280 calories. When x is 280 calories, so the equivalent z-score of 280 calories is negative 2.5. So you will do the same for the rest of the data values. What is the probability she burns more than 280 calories? So in terms of z, this is like looking for the probability that our z is greater than negative 2.5. So we will locate negative 2.5, and then we will shade the region to the right of negative 2.5. That is the probability we are looking for. What is the area of that region? Well, this is what we can do. We can decompose it into two regions. This one, the half, from 0 to infinity, that's 1/2 of the entire region under the curve, and we know that to be equal to 0.5. The area of the region under the curve, all of that is 1. So 1/2 of it is 0.5. And then we will get this. The area of the region from 0 to negative 2.5 is the same as the area of the region from 0 to positive 2.5. We get the sum of these two regions, and that is the probability we are looking for. Okay, so we know this to be 0.5. And then we will look for this. The area of the region under the curve from 0 to 2.5, we will need our standard table for that. 0 to 2.5, let us locate 2.50. 2.50. So 0.5 plus 0.4938 is equal to 0.9938. The probability that she will burn more than 280 calories when she does a brisk walk inside the mall is 0.9938. What is the probability she burns less than 293 calories? Again, in terms of z-score, it's negative 0.875. So let us locate that in our standard curve. It's close to negative 1. We are looking for the region to the left of negative 0.875. Now, the area of that region is the same as the area of this region in the positive side of our Z. Why am I doing that? Why am I showing this? Because the standard table shows Z-scores for positive values. So this is what we are looking for. The area of the region under the curve that is greater than 0.875. We cannot get it directly. Okay? We cannot get it directly. So what we can do is, okay, so what do we know? Well, what we know is from 0 to infinity, the area of the entire region under the curve is 0.5. So to get this area, what we do is we remove the area of the region from 0 to 0.875. We remove this, and what will be left is the area of this region. So what is the area of the region between 0 and 0.875? Okay, let us remove my marks. I will round this off to 0.88. So we begin with 0.80. And then we look for 0.88. So it's 0.3106. So the area of the region we are looking for is equal to 0.5 minus 0.3106, and that is equal to 0.1894. So the probability she will burn less than 293 calories is 0.1894. What is the probability she burns between 285 and 320 calories? This is equivalent to its Z-score, which is negative 1.875, and 320 is equivalent to 2.5. These are their equivalent Z-scores. So we are looking for the region between negative 1.875, it's close here, and positive 2.5. So that's the region between these two values of Z. Let us shade it. So what is the area of this region? So what we do is we decompose this into two regions. First, from 0 to 2.5. Let us get the area of that, and then we will add the area from 0 to 1.875. The area of that is the same as the area from 0 to negative 1.875. Okay, so let us go to the area between 0 and 2.5. 2.50. So it's equal to 0.4938. And then the area of the region between 0 and 1.88, let us round it up to 1.88. It's 0.4699. So we add the two regions, and this is what we get, 0.9637. So how do we interpret this? The probability that she will burn between 285 and 320 calories is 0.9637.